Picture this. You're on a train, speeding across the countryside, crossing city borders, your journey unfolding with every mile. But instead of hours of travel time, the trip is complete in mere minutes. High-speed rail has made this a reality. But how did trains go from sluggish locomotives to the fastest-moving machines on land? Today, we will uncover the mysteries of the world's fastest trains and will journey through history, technology, and the future of rail travel. Why high-speed trains? There is a fascinating paradox that exists in our modern world. We have airplanes that zoom through the skies, but still, high-speed trains have become a symbol of connectivity and efficiency on land. The appeal of high-speed trains lies not just in their speed, but in the unparalleled convenience they offer, especially in densely populated regions where air travel is not always the most practical solution. The concept of high-speed trains is rooted in the idea that transportation should be faster, more sustainable, and capable of connecting people over vast distances. In regions like Europe, Japan, and China, these trains have revolutionized the way people think about travel. High-speed rail plays a pivotal role in reducing congestion on highways and in the air. It provides a reliable and environmentally friendly alternative to both. With faster travel times, high-speed trains are increasingly becoming a viable option for long-distance travel, pushing airliners to rethink their strategies for domestic flights. Trains, unlike planes, offer a seamless journey. There are no security lines or delayed takeoffs. Trains run on time and arrive on time, connecting major cities in mere hours, and in some cases, minutes. In terms of comfort, they beat the cramped airplane seats with more legroom, panoramic windows, and smooth, scenic rides. In this episode, we're going to explore not only the fastest trains, but the underlying technologies that make them possible. From the initial challenges of rail development to the groundbreaking systems propelling these trains into the future, we'll cover it all. So, sit back, relax, and let's begin our high-speed journey through time and technology. Before we can appreciate the speed of modern trains, we must understand where it all began. Railroads have been around since the 19th century, but they didn't become widely available until the 1800s. Initially powered by steam engines, these early trains were a marvel of their time, but they could only travel at speeds of around 30 kilometers per hour or 18 miles per hour. The first recorded trains using steam locomotives appeared in the early 1800s, with George Stephenson's Locomotion No. 1 being one of the earliest engines to successfully carry passengers. By the mid-19th century, railways began expanding across Europe and North America, creating an infrastructure that would one day support high-speed trains. World War II and the dawn of the jet age. The years following World War II marked the beginning of the jet age, with the rise of commercial air travel. Trains, however, were still largely confined to traditional speeds. However, countries with major economic growth, such as Japan and France, recognized that rail travel could be a competitor to the burgeoning airline industry. Japan leads the way, the Shinkansen. 1964, the birth of the bullet train. The Japanese Shinkansen, or bullet train, became the first true high-speed rail service. It debuted in 1964, connecting Tokyo and Osaka. The Shinkansen traveled at speeds of 210 kilometers per hour, or 110 miles per hour, far faster than any conventional train before it. It was not just a symbol of Japan's recovery post-World War II, but also a marvel of engineering. The Shinkansen redefined travel within Japan and became an icon. Its speed and reliability provided a seamless mode of transport between cities that were once a world apart. This innovation spurred a global interest in high-speed rail, with France, Germany, and other nations beginning to experiment with similar technologies. The TGV, Train à grande vitesse. After the success of the Shinkansen, France sought to establish its own high-speed rail system. In the 1980s, the TGV was born, offering speeds up to 300 kilometers per hour or 186 miles per hour. The French TGV system revolutionized rail travel across Europe. The TGV didn't just focus on speed, but also on comfort and efficiency. The trains were designed to have reduced noise levels and high levels of safety. Over time, France developed an extensive high-speed rail network connecting all major cities with minimal travel time. China, the new superpower of rail travel. China's ambitious development of high-speed rail began in the 2000s with a government-backed initiative to modernize its rail infrastructure. The CRH-380A. The CRH-380A is a prime example of China's dominance in high-speed rail. The train reaches speeds of 380 kilometers per hour and can achieve speeds of up to 486.1 kilometers per hour, or 302 miles per hour, during tests. With China's investment in rail infrastructure, the country now has the largest high-speed rail network in the world, spanning over 38,000 kilometers, or 24,000 miles. The CRH-380A and other Chinese trains have set the stage for a new era of rail connectivity. Chinese rail expansion has become a global model, influencing many nations to invest in their own high-speed rail systems. The TGV. The TGV's success is no accident. Over the years, France has invested heavily in improving the TGV's infrastructure. Its dedicated tracks, unique signaling systems, and lightweight designs all contribute to its efficiency. When the TGV hit the 574.8 kilometers per hour, or 357 miles per hour record in 2007, it wasn't just about speed, it was about showing the world what high-speed rail could accomplish. The role of the TGV in modern France. The TGV now serves as the backbone of France's high-speed rail network, and its success has inspired neighboring countries to create their own high-speed services, including Belgium, the UK, and Spain. The Shinkansen. Japan's Shinkansen was a technical marvel from the start. It featured cutting-edge technology, including advanced braking systems, dedicated tracks, and super aerodynamic designs. Today's Shinkansen trains reach speeds of up to 320 kilometers per hour, or 200 miles per hour, and the Alpha X is testing speeds of up to 400 kilometers per hour, or 249 miles per hour. The Shinkansen's reputation for punctuality, safety, and comfort has made it a global reference point for high-speed rail. It's a key part of Japan's identity, connecting its bustling cities and supporting economic growth. The CRH-380A. China's rail network is vast, and it continues to expand at an incredible pace. The CRH-380A is one of the fastest trains in the world, regularly operating at speeds of up to 350 kilometers per hour, or 217 miles per hour, but it has been known to reach even higher speeds in tests. China's plans for the future include developing faster trains and expanding the high-speed rail network to connect more cities. With high-speed rail lines connecting remote regions, China is setting the stage for future rail travel. The Maglev technology. The Shanghai Maglev holds the title for the fastest commercial train, reaching speeds of 431 kilometers per hour, or 268 miles per hour. Unlike conventional trains, the Maglev floats above the track using powerful magnets, allowing it to glide smoothly and achieve extraordinary speeds without friction. While Maglev technology remains in its infancy compared to conventional high-speed rail, the potential for even faster travel is immense. The Chuo Shinkansen in Japan and Germany's Transrapid are examples of Maglev systems that could one day redefine the way we think about high-speed travel. Engineering for speed. High-speed trains are carefully designed with aerodynamics in mind to minimize drag. Using cutting-edge wind tunnel technology, engineers design trains to slip through the air as smoothly as possible. The sleek, futuristic shapes of these trains are not just aesthetic, they serve a functional purpose. To achieve high speeds, trains must be built with lightweight materials like carbon fiber and aluminum alloys, which reduce weight while maintaining strength and durability. Specialized tracks. High-speed rail systems require specialized tracks that are perfectly level, free from sharp curves or sudden changes in elevation. Dedicated tracks ensure smooth, uninterrupted travel at high speeds, minimizing the risk of derailment. The future of high-speed rail. Maglev technology, which uses magnetic fields to levitate the train above the tracks, could allow speeds of over 600 kilometers per hour, or 373 miles per hour. The Chuo Shinkansen in Japan will be the world's first Maglev train to offer commercial service, and other countries are exploring the potential of this technology. The Hyperloop promises to break the speed barrier with proposed speeds of up to 1,200 kilometers per hour, or 745 miles per hour.
This ultra-high-speed vacuum tube system could one day transport people and goods across continents in mere hours. Environmental benefits. High-speed rail offers significant environmental benefits. They emit less greenhouse gases per passenger than both planes and cars, making them an important tool in the fight against climate change. As global cities continue to grow, high-speed rail will play a crucial role in reducing carbon footprints. Future rail travel and its impact. High-speed rail has changed the world by shrinking the distance between cities and making travel faster, more efficient, and more sustainable. The future of rail travel is promising, with new technologies such as Maglev and Hyperloop offering even greater speeds and efficiency. The future of transportation is here, and high-speed trains are leading the charge. Will they become the dominant form of long-distance travel?